Welcome to tutorial for Laplace transform. This is question 2b. In this question, we are interested to find the Laplace transform of ej omega naught t plus theta. So the interesting thing is that we are introducing a phase in the complex exponential. Once we have found this, we are going to use this identity, the Laplace transform, and find the Laplace transform cosine omega naught t plus theta. In both cases, we are interested in the causal signal. Let's begin. Because the signal is causal, we are going to use the unilateral Laplace transform. We plug in the signal ej omega naught t plus theta into the Laplace transform equation. We now will extract out ej theta because simply ej theta is a constant are not related to the integration of t. So ej theta is a constant, we bring it out. We're left with ej omega naught t multiplied by e minus t. So if we put a minus sign in front, then for its minus, then here is a minus becomes plus, getting the expression back. Now we are simply trying to integrate this expression. Let us remind ourselves e minus kt dt. What is the, let's say, from 0 to infinity, and this is simply 1 over minus k e minus kt with respect to t equals to 0 to t equals to infinity. So now we know that our k is simply s minus j omega naught, and if you substitute that above here, you will get this expression. Now remember that k is equals to s minus j omega naught. What is s? S is sigma plus j omega, the complex plane. We need to open up s to be sigma plus j omega because we need to find the region of convergence. So let us see why. Let's ignore minus ej theta first. It's a constant being at the outside. We substitute k into the expression over here and we get this expression. We are interested to see what happened at t equals to infinity. When t equals to infinity, for this whole expression to converge, sigma must be greater than 0. So for region of convergence, sigma must be greater than 0. Otherwise, if sigma is positive, negative value, negative is positive times positive value, it will be infinity. So sigma must be greater than 0, which makes it e minus positive value multiplied by infinity, which will render this whole expression to be 0. That's for the t equals to infinity. So we have when t equals to infinity and sigma is greater than 0, the upper limit is 0. In the lower limit of t equals to 0, when t equals to 0, this whole expression becomes 0, and therefore it will be minus 1 s minus j omega naught, which becomes 1 over s minus j omega naught. So this is the 1 over s minus j omega naught. Here, ej theta came from the constant outside. So now we have the answer of Laplace transform of ej omega naught t plus theta is this expression, ej theta divided by s minus j omega naught. We can then use the Euler's identity to express cosine omega naught t plus theta as the sum of two complex exponential. Here. Now remember that again, we know that Laplace transform is a linear operator. You can simply perform Laplace transform of this plus the Laplace transform of this divided by 2. So this is exactly what you have done here. The Laplace transform of ej theta, so ej omega naught t plus theta. This is causal signal plus e minus j omega naught t plus theta causal signal. You can then put the details here, and you simplify and you will get this expression on the right hand side. So the Laplace transform of this cosine omega naught t plus theta looks like a very complicated expression, but if you look at it carefully, if theta equals to 0, that means we are only left with simply cosine omega naught t, and then cosine of 0 is s, cosine of 0 is 1 times s, so this on top is s, sine of 0 is 0, so this disappears and is s squared plus omega naught squared, exactly like what we have found in the previous question. What about sine? In sine omega naught t is simply cosine omega naught t minus pi over 2. So what we have is, when we substitute minus pi over 2 into theta, we get 0, which is s times 0. So this is 0 minus omega naught, and when we get sine of minus pi over 2, it is minus 1, so becomes plus 1. So it's minus times minus is become plus, divided by s squared plus omega naught squared. So again, it matches. Sine omega naught t is this guy, which is what we have expected, omega naught over s squared plus omega naught squared. So we have figured out this relationship, this more, what do you call that, more general expression of Laplace transform of cos omega t plus theta. In the question, it further asks us to find the pole and 0 of omega naught equals to 2, theta equals to 0, as well as theta equals to pi over 4, and plot the corresponding pole and 0. So to plot the poles and 0, we must study this expression here and substitute values such that the numerator equals to 0 will be the zeros of s. For the poles of s will be the values of s that makes this denominator 0, so they will become the poles of. So for pole, s squared equals to minus omega naught squared. So s is equals to square root of minus omega naught squared equals to plus minus j omega naught. So the pole is sitting on the j omega axis with real value 0, and the pole is sitting at plus and minus j omega naught. What about the 0? The 0 is s cosine theta minus omega 0 sine theta is equals to 0. Therefore, s is simply omega 0 sine theta divided by cosine theta. So this is the answer over here. Now, we then substitute the values of theta to find when is what s should be to make the numerator equals to 0. So you can, so this is cosine omega t plus 0. So the cosine starts from time equals to 0, and because this is u of t, on the left hand side we have 0. This is a causal signal that starts at time equals to 0. So this is the cosine theta. Now, these are where the poles are. This is omega naught equals to 2. So at plus and minus j equals to 2, this is the pole. At theta equals to 0, the 0 is at origin. Because when theta equals to 0, sine of 0 is 0. So it is omega naught times tangent 0 is 0. So it is at the origin. So it's over here. Now, the other one is cosine omega t, omega naught t plus pi over 4 omega naught is equals to 2. So again, our pole is here, pi over 4 in the expression to calculate 0, we know that it is omega naught times tangent pi over 2. Omega naught is 2. Tangent pi over 4 is 1. So it's 2 times 1. So the answer is 2. So it is the real value 2. So we can plot the 0 over here. So this is the pole and 0 plot. These correspondingly are the real-time signal of cosine omega naught t plus 0 phase. Here is cosine omega naught t plus pi over 4. This example is taken from Chaparro and Akin, Signal and Systems. Thank you.